All right, the last part that we need here is distance while braking. So we're going to go ahead and enter that. So distance while braking is the header. And we're going to go ahead and, similar to before, when you want to know the velocity of the car before braking, that's going to be our initial velocity. And this is going to be equal to, I'll make sure it's aligned right, equal to our initial velocity up here. So again, making it so the user doesn't have to re-enter that. It's going to be entered for them, and then in the next cell, go ahead and add the units for that. Then after the velocity, we need to know the rate of deceleration. So we're going to call this deceleration of braking. And this is something that the user is going to need to input and can change based on the scenario and maybe the surface conditions and that sort of thing. So this is going to be maybe for example right now 0.0 meters per second, right? And then this is something that they can change. Then as we go down, we're going to need one more piece of information, and that is the distance while braking. And we're going to use the equation that we've just learned and worked with to solve for this, but we're going to put it over here in the distance outputs as we're going to make it calculate it for us. And again, that'll be meters. So I'll put that over there as well. And here we go. So this is, again, something that we want this cell to be equal to. And we want it to match the equation we've just learned. So we're going to write it a little different, but very similar. But it's going to start with an equal sign. Start with an equal sign. And then you're going to use a parenthesis, 1/2. If you remember back to our equation, it was half times the initial velocity squared divided by acceleration. So this is half times, and now I'm actually going to start another parentheses. And again, my advice to you when we calculated the braking distance was to take the initial velocity squared divided by acceleration and try and solve for that and make it one number. So with these parentheses, we're going to tell the program to do that. So you're actually going to use a second parentheses now to do the initial velocity squared. And the best way to do that is after you do the second parentheses, we're going to go ahead and really you could select any of these, but that original number, so C4 times C4. Just because it's a little difficult to do a squared symbol, and so that's just an easy way to have it multiply by itself. So that's the same as writing the initial velocity squared. Now we're taking that number divided by the rate of deceleration. And now that whole thing is in the parentheses. So you end parentheses there. And so when you hit enter on this, it should complete the equation for us. Now, it's going to give you a little warning that you can't divide by a value of 0. So once we enter some practice numbers, let's look at this. Let's say we have initial velocity of 10. Okay, 10 filled in all those spots. Perfect. Let's say they were distracted for 2 seconds. Again, just checking out the equation. 10 meters per second, 2 seconds, 20 meters. Okay, that's looking good. 10 meters per second here. Let's say it took 0.2 seconds or 200 milliseconds. That was a pretty average reaction time that I saw. Okay, that means they traveled 2 meters while reacting. And then our rate of deceleration, one of the standards, if you will, so let's use that as an example, was 4.5 to 6. So for the sake of simplicity, let's try 5 as our rate of deceleration. And our distance while braking now was 10. Okay, so then that's going to bring us uh, hopefully an accurate number and to the kind of the finale here. So we want in nice big letters total distance car travels, okay, equals, and this is going to be another kind of calculated output, if you will. So I'm going to move that over, and then let's make this a darker red. This is kind of like the big number, and this is going to be equal, this cell is going to be equal to our distance while distracted plus our distance while reacting plus our distance while braking. So if I just select E8, okay, this first value here, plus sign, our second value here, plus our third value with the distance while braking, and hit enter, that is going to be 32 meters. And I can kind of make that look a little cleaner because this is super important. Let's go ahead and make it a little bit bolded and large. Oops. Let's go ahead and make this a little larger as well. There. Okay, so now that kind of fits in there, looks good. Total distance right here. And then to cap off our simulator, we also need to know the distance to the walker. So this is something that the user might input at the beginning of the scenario. And because we use, well, I'll go ahead and enter. But because we used blue over here, let's go ahead and signal that this is a certain value that's important. We'll make the size a little bit bigger, change the text, and let's just go with our royal blue text. Okay, so now distance to walker, this is going to be a value that they put in, so we're going to make it green. And it's going to be in meters. So it could be 50 meters. Okay, and so now we're going to be able to determine, okay, is this value shorter or larger than this value? And in the next video, we'll look at these tabs and kind of help our program determine for us if the pedestrian is going to be safe or not.